Integrated Math 2, this is lesson 1.08 on the missing side. So we're continuing with trigonometry using sines, cosines, and tangents. Let's go ahead and start off by writing the relationships here on the front page. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. All right, so what we're given in these problems, and you're going to need a calculator for these, and you're going to need a calculator that has sine, cosine, and tangent. So your cell phone may or may not have that if you're at home, but you certainly have these calculators in the classroom. So what we're given is an angle in addition to the 90-degree angle. This must be a right triangle, a 90-degree angle, or everything we're talking about would not apply. So in addition to the right triangle, you have one angle and one side. And using that, you can find the other side. In fact, you could find both other sides, but we're only asked to do one, so we're just going to do one. So the first thing you do in any of these problems is you label the sides. So the longest side is the hypotenuse. It's this side right here. The opposite is the side that's on the opposite side of the triangle from the angle that we're working with. So 47 degrees. So you come across here, and this is the opposite. And then the adjacent is the other guy. And that's that side right there. So what you want to do is find out which two sides you're working with. One of them is got a known length to it, and the other is the unknown that you're trying to find. So you're trying to find a relationship between those two and that angle. So what we're dealing with here is the opposite, which is our unknown, and the hypotenuse, which is the value we're given. So we want the function up here that has opposite and hypotenuse in it, and that would be the sine. So I always recommend you write down the relationship every time, and then you'll end up memorizing it. Okay, so it's opposite over hypotenuse. So now we'll go ahead and apply numbers. The sine, now a sine, cosine, or tangent is always of an angle. And that angle is 47 degrees here. And that's going to equal the opposite, which is our unknown, over the hypotenuse, which is 10. Okay, so what we do is we go to the calculator right here. Okay, and there's the sine button right there. So we're going to push that button. We have to be sure our calculator's on first. Push the sine button, and there you see sine has shown up. Now you have to be sure that it's set for degrees down here. There are three possible settings that it could have: degrees, radians, which would be RAD, and gradient, which is GRAD. We never use gradient. We might use radians in this class. If you don't, you'll use it in Integrated Math 3. But we want everything set for degrees. We're working in degrees, so that should say DEG right there. DEG. Okay, so the sine of our angle is 47 degrees, so we're going to put in the 47. And you want to be sure to close the parenthesis whenever you have an open parenthesis. And so now we're simply going to hit equal. And we get 0.731. I'll go to 3 places after the decimal. So this number is equal to 0.731 equals x over 10. And now it just becomes an algebra problem. You need to solve for x. So we have a 10 down here, so we're going to multiply the top by 10 and both the other side by 10. The 10s here cancel. And I'm going to put the x over on the left side of the equal sign. I'm just going to reverse the equal sign. There's no big deal there. So I have x equals, and 10 times this number right here is going to be 7.31. So what does that mean? That means this side over here is 7.31. Whatever unit. It could be feet, inches, miles, whatever it is. It's 7.31. And that's how you do these problems. Okay. So let's go ahead and do number 2. So here's the angle we're dealing with right here. It's 37 degrees. First thing is we label the sides. This is the longest side. The hypotenuse is always the side opposite the right triangle, or the right angle, excuse me, the right angle. So, but usually it's obvious which one the longest side is. So it's this side over here. So that's the hypotenuse. The side that's opposite the angle that we're working with here, that's this side, that's the opposite. And the other guy is the adjacent. Okay, so we've labeled our sides. Now we have to find the side that we're interested in finding the length of, and a side that we're given a value for, a number for. So in this case, we're looking for the adjacent and we're given the hypotenuse. So we want to find the relationship that includes adjacent and hypotenuse. We come up here and we see that that's the cosine. It's adjacent over hypotenuse. So again, I'm going to go ahead and I'm going to write cosine just the general relationship. Write it every problem and you'll end up memorizing. So the cosine of what? The cosine of this angle. A cosine, sine, or tangent are always of an angle. And that's going to equal the adjacent, which is x, our unknown, over the hypotenuse, which is 20, which is our known. Okay, so I'm going to go to the calculator and figure out what cosine of 37 is. Okay, so we come down here, we find the cosine button right there, we press it and it shows up there, and we're interested in 37 degrees. Okay. And then we close the parenthesis and we hit equal, and we get 0.798, but I'm going to round that up to 0.799. So this is going to be okay. Now again, we just have an algebra problem. Multiply both sides by 20. That cancels. And we end up with x equals 20 times this number. And that gives us 15.98. So that means this side right here is 15.98. Right there. Okay, let's keep going. Again, try to do these on your own. Don't just copy. Try to do them on your own, and then, give it at least a minute worth of thought. Okay, how do you do this? Write down. Even if you're wrong, if you try it and then you see me do, and you're wrong, and you see me give the correct answer, it will stick with you. The answer you'll remember because you at least tried. If you don't even try, you just wait to watch me do it, you won't remember it. You will have nothing in your mind to compare my answer to versus your answer, and so you won't remember the answer. So I ask that you do that. Okay, so here we go. The hypotenuse is the long side right here. The angle we're interested in is the 33 degrees, and the side opposite that is this side. And this is the other side. So we're interested, here we have our unknown is the hypotenuse, and our known is the opposite. So opposite hypotenuse is going to be a sine. Okay, so now we're going to plug in the numbers. Sine of 33 degrees. It's going to be 17 over x. Adjacent over, opposite over hypotenuse. Okay, now we are going to figure out what sine of 33 is. So we come over here, and here's the sine button, and 33, close the parenthesis, hit equal, and we get 0.544. And now we solve for x. Now, because x is in the denominator here, it's going to be a two-step problem, but it's still just an algebra problem. So we multiply the top of both sides by x. These cancel. And we have, I'm going to go ahead and we usually put the number in front of the variable x. So 0.544x equals 17. Now to solve for x, we divide both sides by 0.544. These two go away, and you have x equals 17 over 0.544, which equals that's going to give us 31.25. Okay, so x equals 31.25 is your answer, and that's the length of the hypotenuse. All right, so let's go ahead and move on. Okay, here we go. So first thing we're going to do is label. The long side is this side over here. The angle we're interested in is this angle right here. So the side opposite this angle is over here. So that's going to be the opposite. And this side is the other guy. Alright, so the side that has the known value and the unknown that we're trying to find, x. So opposite is the unknown, adjacent is the known. So we want to find the function that has opposite and adjacent. And if you look back on the first page, that would be tangent. So tangent equals opposite over adjacent. So now we'll plug in the numbers. Opposite is x. Adjacent is 17. Multiply both sides by 17. And we have x equals this. And actually, I'm going to do this a little, let's do it a slightly different way. Instead of finding the tangent of 70 right at the beginning, as I did in the earlier problems, I'm now going to do this as one big calculation. You don't have to do it this way if you find it confusing. But I have 17 times tangent 70. So here's my calculator. And it's going to be 1717 times, now I'm going to hit the tangent button, and then 70, close the parentheses. So you see you can do all this in one big calculation like that and hit equal. And that gives me 46.7. So that's the value of x. If you didn't like that, if that was too many steps on the calculator, once you don't have to do it that way. So that's our answer down here. This is 46.7 is the value of the opposite of x. Okay. All right, let's keep going. So the long side here is the 15 side. That's the hypotenuse. Here's the angle we're interested in is 30 degrees. And this unknown side, well, the opposite is over here. Opposite of this angle, straight across. So this has to be the adjacent, the other guy, right there. So our unknown is the adjacent, and our known value is the hypotenuse. So the relationship between those is the cosine. Now we'll put in the numbers. Cosine of 30 degrees. Adjacent is x. Hypotenuse is 15. Okay, again, I'm going to go ahead and do it a little more sophisticated way. I'm going to multiply both sides by 15. These cancel. So what I have, I'll rewrite it down here, is x equals 15 times cosine of 30 degrees. So that's the way I'm going to put it in the calculator. So I come right here, and I have 15 times cosine 30, close the parenthesis, and we get 12.99. I'm going to call that 13. So this equals 13. This side right here. Right, again, you could stop, go back, watch it again if you don't understand something. Be sure that you can do these on your own. Even if you say you completely understand what I'm doing, be sure you could cover up that answer, turn off the video, and see if you can do it on your own. Okay, that's the important step. Okay, all right, we got another one. Going to keep going. So this is the hypotenuse over here. Here's the angle we're interested in is 60. The opposite is that 12 over there. That's the opposite side. And this is the adjacent. So our unknown is the adjacent and our known is the opposite. So the function that has a relationship between opposite and adjacent is tangent. Okay, so now we're going to plug in the numbers. So the tangent of the angle 60 equals 12 over x. Okay, so now we need to solve for x. It's in the denominator, so it's a two-step process, and that should be 60. So we're going to multiply top of both sides by x. Cancel, cancel. And now what you have is x times tangent of 60 degrees equals 12. So now what we need to do to get x by itself is we need to divide both sides by tangent 60. And this goes away. And so we have this. Okay, so if you're more comfortable doing this, just go ahead and put the 12 over here. I'm going to scratch out the page number in the way. And I'm going to take the tangent of 60. So tangent 60, close parenthesis, gives us 17.32. Okay, and so when you 12 divided by 17.32 is going to equal all right, and I made an error. It's not 17.32. It's 1.732. You don't really need to go to that many decimal places, but I might as well since I already have them there. It's 0.732, 1.732. So it's going to be 12 divided by 1.732. And what I did is I saw that answer did not seem like a reasonable answer. So I went back and recalculated. So here we go. 12 divided by 1.732. Whoops, got that one wrong. 732. And that equals 6.93, we'll call it. So that's the value of x. I'll write it over here, 6.93. And that's your answer for that. Okay. Okay, so here are the answers to 7 and 8. Those are going to be you problems. You do those. Again, you have to show your work. You can't just write that down. All right, so you do those two. They're done exactly like the ones before. Okay, we're going to finish up this assignment with 3 word problems. So number 9, a hot air balloon is 100 feet straight above where it is planning to land. Destiny is driving to meet the balloon when it lands. If the angle of elevation to the balloon is 35 feet, that's from where she is at that time, how far away is Destiny from the place on the ground where the balloon will land? Okay, so let's just draw a little diagram. Here's a balloon. Okay, and here's Destiny in her car. Okay, so she's looking up at the balloon like this. So that's one side of the triangle. The other side is going to be the ground, so we want that to be level here. And it's 100 feet straight above where it's going to land. This is where it's going to land. So it's 100 feet above that right here. So that's 100 feet. All right, so that's 100 feet. And the angle she's looking up at is 35 degrees. And the question it's asking is, how far is Destiny from the place on the ground where the balloon will land? So this is the place on the ground. This is her. So it wants to know this distance x, that distance right there. All right, so now it looks similar to the other problems. So you got to label the sides, hypotenuse. Here's the angle, so this is the opposite. And this is the adjacent. So it wants to know this side, not the hypotenuse. It wants to know the adjacent. So the relationship we have is we know the opposite. We're trying to find the adjacent. So that would be a tangent. There it is. That's the relationship. So let's put the numbers in. I'm going to come down here and calculate the tangent of 35. There it is. Close the parentheses. And we get 0.700 equals 100 over x. So we're going to multiply both sides by x. Cancel, cancel. Now we got to get x by itself here, so we have to divide both sides. Let's rewrite this. Divide both sides by 0.7. And I'm going to kind of sneak over here and finish the problem. Okay, so the 0.7 here cancels. And so you have x equals and that's 142.8. Okay, so that is this side right here. So she's 142.8 feet away from where the balloon's going to land. That distance right there. All right, let's keep going. So a plane that is cruising at an altitude of 30,000 feet wants to land at Bush Field. It must begin its descent so that the angle of depression to the airport is 7 degrees. What is the horizontal distance? Horizontal is this way from where the plane begins its descent to where it lands at Bush Field. So here's the plane. Okay, and it's going to land over here somewhere. We'll just say it's right there. So the plane is going to come down at this angle. Let's get that a little straighter there. All right. And it's originally going in this direction. So we're creating a triangle here where it says it's 30,000 feet above the ground. The ground is down here. So this is 30,000 feet. Okay. And what it wants to know is what the 7 degrees is the angle of descent. So that's 7 degrees. So it's going horizontal. It's just flying above the ground at the same elevation. And now it's got to descend down at an angle of 7 degrees to get to the point where it's going to land. So it wants to know what is the horizontal distance from where the plane begins its descent to where it lands. So it's not asking for this. It's asking for this. That's horizontal. So it starts off here and it's going to land here, but that's even with this. So it's really asking for this distance x right here. It's kind of a little unusual. You know, usually they might ask how far did it travel to descent. But anyway, that's what they're asking for. So the hypotenuse is the long side. Opposite the angle, 7 degrees, is the opposite. And the other guy up here. So our known number is the opposite. Our unknown that we're trying to find is the adjacent. So that's going to be a tangent function. Tangent of 7 degrees. Okay, and that's how you would set up this problem, opposite over adjacent. You're going to multiply both sides by x. Cancel. And divide both sides by tangent 7. Let us just rewrite this down here. Okay, we're going to divide both sides by tangent of 7 degrees. And this cancels, so we have x equals . So I'm going to do this all in one calculation the way I did one of the problems earlier. Put it right here. So it's 30,000 divided by tangent of 7. Sure you can see that. And close the parenthesis. Okay, so I divided 30,000 divided by tangent 7, and I hit equals. And I get 244.3 miles. So that means this distance right here where the x is 244.3 miles. Okay, again, it's this distance right here, not this distance here. And that's what they asked for, horizontal distance. That means that. Okay, let's finish up one more. And this one I'm going to just kind of set up for you and let you finish it, okay? So this is kind of a U problem. I'm going to do part of it with you. So Allie is practicing hoops for the next trash ball math review game. Her eyes are 5 feet above the floor, and the angle of elevation from her eyes to the hoop is 20 degrees. The height of the hoop is 15 feet. How far away is Allie from the base of the basketball hoop? Okay, it's a little bit of a tricky one. Let's see what's going on here. So let's draw this picture. We got a lot of space here. So here's Allie. Here's her eyes. Okay. She's 5 feet above the floor. She's looking up, and this is not to scale, but I'm doing, close. She's looking up, and here's the basket right there. So it says the height of the hoop is 15 feet. So the height of the hoop above the floor, so let's draw the floor along here. So this is 15 feet. Okay. And it says, how far is Allie from the base of the basketball hoop? So that's this distance right here. Okay. Well, that distance right there is the same as this distance right here. The reason I say that is because this doesn't form a triangle down here, but this does. So this side and this side, let's just go ahead and label it. It wants to know how far she is from the base of the basketball hoop. That's this distance. So we're going to call that X. But working with this triangle up here, this is X also. In other words, from here to here and from here to here are the same distance. This is the distance they actually want to know the answer to. How far is she from the base of the hoop, where the hoop touches the floor? But that doesn't form a triangle. We have to come up here to form our triangle. So that distance down there is the same as this distance from here to here. So this is X, this is X. Okay? Now, she's 5 feet tall, and the hoop, the entire hoop distance is 15 feet. So I'm going to erase this and rewrite it. So this entire distance is 15 feet. Okay, this distance is her height. Right there is right there. That's 5 feet. Okay, because this is level with her eye, and that's 5 feet. So that means this distance is 10 feet. 15 feet total minus the 5 feet of her height. So this is 10 feet. Okay, and it says that the angle of elevation from her eyes to the hoop is 20 degrees. So this is 20 degrees. Okay. So here's what we're interested in. We're interested in this side, and this angle. So now that we have all of that done, I'm going to write over here what we're really interested in. We're interested in this. That's the X. That's the unknown distance she is from the base of the hoop. Then this side of the triangle is 10 feet. And then the hypotenuse of this triangle, we don't know, but we know this angle is 20 degrees. So from all of this, I got that triangle for us to work with. So that's a fairly complicated problem, so I'm going to go ahead and do it with you. This is definitely a problem you should practice. Again, once you see my answer, cover it up, go get a clean piece of paper and write it out, and be sure you can write this problem out. Okay, so we're going to label our sides here. Hypotenuse, this is the opposite. This is the adjacent. And the sides we're interested in is the unknown, the adjacent, and the known, the opposite. So that's going to be a tangent. So we'll put numbers to it. The tangent of 20 degrees equals the opposite, which is 10 feet, over the adjacent, which is unknown feet. That's what we want to know. That's the final answer to our problem. So we're going to multiply both sides by X. Cancel. And now we're going to divide. Let's go ahead and rewrite it down here. X times tangent of 20 degrees equals 10. If you want to go ahead, I'm off screen a little here. If you want to go ahead and figure out tangent ahead of time, you can do that. Just showing you different ways you can deal with this. So I'm going to bring this over. Okay, and we've got tangent of 20 degrees. And that's going to give us 0.364. So this number is 0.364 equals 10. We're going to divide both sides by this, 364. That goes away. And X equals 10 over 0.364, which is going to equal 27.5. feet. So this distance, both of these distances, the one they're interested in is how far is she from the base of the basket, is 27.5 feet, and that's the answer to that. Okay, that one's a complicated one, okay? It required a complicated drawing. And anyway, that's a good one to practice because it's difficult, so just keep doing it until you understand the reasoning behind every step, okay? That takes care of this lesson, and we'll see you on the next lesson.